When we heard Ford was making a nearly $325,000 Mustang, I literally laughed out loud. In the modern world, most fun vehicles have become unobtainium and horsepower obsessed. Supercars are now a dime a dozen and end up either rotting in someone's garage or drag race for clout. Luckily for everyone, Ford allowed us to share their engineering story and technical details from the people who did the work on the back end. Not only that, they handed us the keys to drive it flat out at Autobahn Country Club to determine if that effort and price tag is justified.
I'm Greg Goodall, the Chief Engineer of the Mustang GTD. Mustang GTD really came out of the Mustang GT3 race car. Shortly into development, Jim Farley saw the car and said, we need to do a road car version of that. On any given weekend, we're racing Mustangs somewhere around the globe. So we wanted to make sure that we could compete with those same manufacturers in a supercar space. It doesn't have a typical supercar silhouette. If you approach the car, it is very clearly a Mustang.
GTD is, as much as we can, the road-going version of our GT3 race car. GT3 actually started from Mustang Dark Horse. So we went road to race and race to road. We've gone full circle, basically. The whole point of doing GTD was keeping it as close as possible to our race car. GT3, per the rule book, actually allows us to change quite a bit of the bodywork compared to a Mustang Dark Horse, a production car. So a lot of things we did on GT3, like moving the main air intake at the front, being lower in the front fascia instead of a big grille up top, works just better for aerodynamics and better for cooling. It's better performance for the car. The front fenders, the vents, the hood vents, the rear wing, the rear diffuser, the wide body, the fact that the car is more than 2 meters wide on GT3, all of that stuff, you usually don't get it on a road car. So when we decided to do GTD, the whole goal was take all of this and find a way to put a license plate on it.
So working as a small team is really one of the things that enabled this project to be successful.
We worked with Multimatic because we did GT3 with Multimatic, and they do GT4 as well for us, and even Dark Horse R now with the suspension. So it was just the logical next step. If we're doing a road car, we did the GT with them before. It was same team, same people we would talk to. We had the relationship. So the plan was, I think, always to go with Multimatic. That was a no-brainer. We knew they were going to deliver a good car. And then because we did GT3 and we very organically moved into GTD, basically from a program standpoint. A lot of the key players from the race program actually transferred over to the road program. So it was a pretty seamless transition. And then it was just a team effort. We were like, you know, all these stories where, oh, it was designed or built in a shed. Well, it was designed and built in a shed. We were inside a steel building behind the wind tunnel here in Michigan. And it was a very small team. There was just 10 of us over there and nobody else knew about it. Officially, it was storage parts and warehouse. We weren't building a car there. We weren't designing a car. So, and we had all our meetings. Multimatic team would come over, and 2 or 3 times a week we would just sit down around the table and look at every part of the car and go through it together and figure it out together. So there's no real like Ford stops here, Multimatic starts there. It was a lot of back and forth between the two teams. We have our ways of doing things. Multimatic has their ways of doing things. And then you have the motorsport way of doing things. So we kind of like mixed all of this and came out in the end with the product that we have today.
Can you believe it? Business deals!
So not only do we have to design this car, we then have to be able to build it. Our high volume plants are really good at a lot of things, but there's certain things that are very challenging in that environment. So we had to move to basically a hand build process at Multimatic, where we could make the carbon fiber panels, or we could fit them to the body, where we could put it through a very specialized paint process that has an infinite palette of colors. So we need to have the flexibility that our operators and technicians can easily get to the vehicle. So we don't have a lot of automation in our assembly process. It's all by hand because people are climbing in and out of the car, putting things where they need to be, securing all the fasteners. The craftsmanship has to be top notch. Our customers expect the best. So you only do that by hand fitting body panels, by having operators meticulously looking at the vehicle, inspecting it. So you can't do that on high volume conveyors and running through 100 different stations in the plant. You run through 10 different stations that are all manually building the car. You're literally pushing the car from one station to another. The manufacturing process is a huge challenge, but the flexibility of doing that in a low volume niche plant with technicians that are used to this type of quality, this type of work, is key to the success of this product. We still have targets for how long it takes to build a car. Of course, we make sure that we take the time to do every step right, but we do need to make production volumes. So it's a pretty regimented process. Even though it is all by hand, there's set times for how long each step can take, but we always make sure we take the time to do it right and make it perfect.
I think everybody, every big OEM, which has a lot of history, has best practices. And you have to have that if you want to have consistency and good craftsmanship throughout your vehicles over the years. So for a niche vehicle like this, sometimes it helps because it gives you boundaries. Sometimes it slows you down because it's more of a hurdle and you need to request an exemption or something like this because this rule that rule was made for the execution of an SUV or something like this. A vehicle like this being kind of like taking the recipe and not throwing it out the window, but putting it in a very different universe, gives you some challenges, I'm not gonna lie. But I think as a team, it was great to have Multimatic on board because they're a much smaller team, so they can react really quickly. And the fact that for us, this was very much a skunkworks program. While we were doing this, until we actually presented the car at Pebble Beach, you had probably 60 people in the whole company that knew about it. That was it. And I'm counting all our CAD modelers, all our clay modelers, like everybody. There's about 60, maybe 70 people. Very few people that had power of decision making, so it kept it simple, it kept it fluid, and it kept it fast. And that's where we've been very good. And we've used that program as a reference for other programs now on how to be more agile, how to react better and faster and find more solutions in a shorter time frame and kind of think outside the box as well. So it's, in many ways in the company, it has shaken things up and changed the way we work. road cars are always a lot more difficult than race cars to design and engineer because you have to meet homologation regulations and several sets of requirements, crash testing and all that. So the race car, everything is just driven by performance. If you get some styling on it, I always say it's great. If you don't, well, as long as the car wins races, I think people are happy. So, you know, there's plenty of very famous cars that are very ugly, but if they won Le Mans, people love them. The other way doesn't work that well. There's plenty of pretty race cars that have done nothing and you forget about them. So the race car is always easier. You have one goal and it's performance. So everything you design must be driven by performance. The road car, it needs to go up your driveway. It needs to, you know, go on a lift at the dealership. You need to be able to drive it to work if you want. You need to be able to drive it in the rain on the Autobahn in Germany. There's so many different conditions, environments that it needs to live in. A race car lives in a very controlled environment. That's the racetrack and that's it. The road is a much harsher environment for a vehicle. So taking race vehicle design and putting it on the road is the hardest part of the exercise, is preserving that while making it something that anybody can drive, not just a race car driver. We put, you know, our racing drivers are super talented drivers. A road car, anybody needs to be able to drive it and be safe in it. And the design side of that is, what do you keep of the race car and what do you get rid of that doesn't matter so much on a road car? So there's a few things you need to take care of on a road car, like, you know, stone pecking, for example. You don't want the entire body side of the car being destroyed by stones when you're driving on the road. So you got to take care of that. You want to preserve your aero performance that you have on race car. You want to preserve the balance, which is the main thing on track. If you have a car that has too much front end or too much rear end, then your lap times are not going to be good and it's not going to be safe to drive. So you have to balance all of this and at the same time integrate all of that with all the homologation rules that you have around the globe. They're not the same in the US, they're not the same in Europe, they're not the same in the Middle East or Asia. So you have to take all of this into account, which is, it's a massive jigsaw puzzle and you're trying to put all the pieces together to get to the perfect or the best vehicle you can at the end. GTD compared to what I like to call a regular Mustang, like a Mustang GTD or Dark Horse, is extremely different in terms of bodywork. The management of the airflow around the car, both for downforce and cooling, was at the forefront of every decision we were making on the car and while we were designing it, working on the clay model. It was on everybody's mind, top subject. So the whole airflow around the car, managed from front to back, is completely different. The car has what we're calling a bottom breather. So the front end, the main grille is actually in the lower fascia. That's where you get most of your cooling. The top grille is actually smaller than on a regular Mustang because you don't get that much airflow in that area. We have the airbox inlet has been a huge struggle to get all the power out of the engine. So we actually feed the airbox through the regular intake, and then there's a second intake that snakes just under the surface of the hood and feeds on top of the airbox for extra airflow. So that's one of the things on the front end. We also have the two coolers in the front, which for example the race car doesn't have. So the race car is all flush and clean. The road car, we need to have the coolers there because you can't put them in the back, for example, or you can't stack them due to the packaging. So having to manage that airflow for us was critical as well. We wanted to have enough airflow to it so they work well, but we didn't want them to create unnecessary drag. So the whole front fascia is basically built around these three elements. And then after that, all you're managing is hot air evacuation through the hood, through the front fenders with the fender vents. You're venting out the positive pressure from the fender vents to actually generate downforce on the front end. So your fender vents work with the front splitter and the underbody of the car. For example, the fender vents, we ran about 120 something designs on it before we got to the one where we were like, this is it. We're happy with it. We're happy with the performance and we're happy with the looks of it. So those vents are absolutely critical. And then all the airflow coming out of there, you have to manage that on the side of the car and also coming over the rear fenders and the rear wing. So the whole back end is also designed to manage this. The intakes on the side before the front wheels, they're actually there to also create what we call an air curtain. So they don't feed into the brakes or anything, because we feed the brakes from the underside, from the flat floor. But the side vents actually blow air right on top of the rear tires and just in front of it. And it creates a little bit of a cushion of air in front of the rear wheel, so that all the negative airflow and the bad airflow coming out of the rear wheel just gets killed. And you actually reduce a lot of drag by doing that. So that was one of the little tricks we had. On the race car, that vent actually feeds into the brake ducts. But we couldn't do this on the road car, so we actually used it for a different purpose. So the GTD without track pack has a smaller front splitter. It has the same rear wing, but it doesn't have active aero. So we built that package. That way we tested it, we balanced it, we made sure it worked. And then on top of that, when we created the track pack, we added the bigger front splitter, which gives you more front downforce, which meant that we had to also manage like how much airflow we get. It was getting us more airflow under the car, and we also had to manage the airflow on top of the car a little bit differently. So you get the gurneys on the hood in front of the hood vents, which help us actually evacuate a little bit more air from under the hood. And then as you get the track pack, you also get the dive planes in the front, which the base car doesn't get, and you get the active aero. So the active aero actually allows you to constantly manage your downforce front to back. So that's what allows you to get a little bit more out of the car while keeping the balance that we're looking for in a vehicle like this. We have a hydraulic pump in the trunk of the car, and that is controlling the rear wing. The rear wing is two different flaps. You have the bottom flap and the top flap. The top flap is the one that moves. So in regular driving, the top flap is what we say closed, so it gives you the most downforce. That pushes the rear end of the car down. And then under the front end of the car, it's all flush and smooth. So you get really good airflow, you get really good downforce from the underside of the front splitter and into the underbody of the car. As soon as the active aero comes on and you're reducing the drag at the back by flipping the second flap horizontal basically and opening the gap between the two flaps on the wing, there's two elements that deploy under the front end of the car to actually generate a little bit of turbulence under there and reduce a little bit the downforce on the front end of the car. So because we're reducing the downforce on the rear, you need to reduce the downforce on the front end as well, so that the back end of the car doesn't become dangerous. Because at the end of the day, when you're doing this, that's when you're at top speed. And you don't want your car to start being squiggly and a little bit on the edge. So as we change the rear downforce, we change the front downforce as well. Like I said, as it works as a package, any little change on the front end, like the flaps are really small, but any little change on the front end actually impacts all the airflow under the car. So everything moves with it. And then all of this talks to the Multimatic suspension at the same time as well. So it's a pretty big computer, like it's a pretty big brainy system in the car basically.
There's an elephant in the room, and that is weight. Because the GTD reuses the existing Mustang's body in white, this car is 4,432 pounds, which for reference is over 400 pounds heavier than the Dark Horse. We had an extended discussion with the team as to why they went in this direction.
The Mustang GTD is a pretty big car, there's no denying it. We started from Dark Horse, homologated GT3 from Dark Horse, and then GT3 per the rule book, the maximum width is 2,050 millimeters wide. And that's, everybody's there, it's the same for everyone. When we started GTD, we looked at how to make it that width, because usually any production vehicle that's more than 2 meters wide, you need to start having like the 3 little lamps like you have on a Super Duty and on some trucks. So we looked at that, and honestly, on the Mustang, 3 little peanut lights don't look very good. So, but there's a little bit of a loophole in the system which actually allowed us to go even wider than the GT3 car. So like the GTD production car is even wider and more aggressive than our GT3 race car, which I think is pretty much unheard of in their history. But that allowed us to actually package the 325 and 345 tires, which allowed us to package bigger brakes and have a better suspension geometry so that we could really take the base Mustang chassis, because this literally starts off of a body in white of a regular run-of-the-mill Mustang. This is the same base body in white as a Mustang EcoBoost. And we go in, we chop off a few bits, and then we bolt on all the extra stuff, all the goodies, all the good stuff, and we make it into a GTD. So it starts as a Mustang, really. It has the bones of the Mustang, the subframes, the frame rails, all of this is Mustang. So we had to work around that and build around that. And when you want to take that much performance out of a vehicle like this, you have to make it wider. You have to make it bigger. You have to put a ton of aero on it. So that's basically what we did. And that gave us, GTD is over 2 meters wide.
At this point, we were concerned this was going to be yet another big, heavy car. However, things started to come together as we had Multimatic and Ford Performance Engineering at our shop. Under the skin was where things started to make more sense. The GTD was a ground-up rework of the entire car's suspension, drivetrain layout, and braking system.
So goals for GTD were pretty simple: to make the best handling and highest performing track car that Ford as a company has ever produced. As far as benchmarks, we looked back towards our successes in the past, Ford GT obviously being one of the main ones, and this has benefited from some of the technology we used on GT, that being the dual ride height, the spring rates that are variable both in the street and in the track configuration. But we want one better, adding in adaptive shocks to the GTD for improved basic performance both on road and on the track. As far as external benchmarks, it's not something we talk a lot about, but I think you guys can probably guess that for the most part they have letters and numerals in their model names. So there are huge architectural changes for GTD, as you'd imagine. One of the best things about this program was being given a very, very open design writ in what we were able to do both in the suspension and also the physical design of the car from an aero perspective. From an architecture standpoint, there is definitely some carryover from the 650 platform. A lot of the front body in white is retained. The front end, the architecture allowed us to basically move from the strut to what is a multi-link SLA style suspension with a coil over shock and spring architecture on it. The primary benefits of that are, one is obviously the improved lateral stiffness, because you don't have to deal with strut bending anymore, and you've got arms that are directly resisting the lateral loads going into the vehicle. You're also able to more finely tailor the kinematics because the upper and lower control arms allow you to place things like the steering axis and also the front and lower ball joints in more optimal places for things like camber gain. So you get improved kinematics out of the wheel end, improved grip on the front end, better stiffness out of the front end, and overall an improved driving experience from caster stiffness perspective, and also a cornering camber stiffness perspective, making it the most direct and feelsome front end a Mustang has really ever had. In the rear, a lot more open. Basically, most of the rear of the car was cut out, and GTD gets a bespoke tubular subframe along with bespoke arms for basically suspension for kinematics optimization, a bell crank system basically with pushrod suspension, which not only allows us to change motion ratios, getting to either rising or falling rates depending on which mode you're in and kind of what position the car happens to be in, but also to relocate the loads into an area that's much, much more rigid and much more capable of handling the high aero loads and the high tractive loads that the car is able to produce with a 325 front and a 345 rear tire. The kinematics on this car are particularly challenging because we have to have optimal kinematics in both of the ride heights. So we have to have good kinematics for the on-road as well as the lowered track positions for the car. Based on the additional space that we've had, we've been able to improve both the camber compliance, get the roll centers in places that are a bit more optimal for better power down, even with the 345 rear tire, which obviously is a huge advantage, but still can use every little bit of help it can get with the engine that we have in this car. And in general, we've been able to better optimize pretty much all kinematics just as a function of having the space to work with. So the Multimatic ASV system allows us some significant flexibility and removes a lot of the trade-offs you would have in a vehicle that has this amount of capability and this amount of aero. In a conventional vehicle with this amount of aero, you tend to end up overspringing the car because you have to deal with, one, providing a stable mechanical platform so that the aero balance isn't shifting fore and aft as you run into ground effects as things get closer or farther away from the ground. And then two, you also really need some aero platform stability. So you don't want the body moving around significantly under high levels of lateral acceleration, longitudinal acceleration, those types of things. And in a conventional system, that, or race car, dedicated ones, that results in very, very high rate springs. What the Multimatic system allows us to do is basically put two springs in series on the same coilover, one of which is a low rate ride spring that's primarily used for on-road, and one of which is a much stiffer track spring, which of course the track is using in track mode, or the car is using in track mode. So when the driver puts the car into track mode, it collapses the spring seat on the lower rate ride or on-road spring. And now the only spring that's acting in the suspension is that much, much higher rate track-based spring. What this allows us to do is to remove that harshness and the punishing ride that you'll get with a very, very capable aero car in the on-road, but also provide the stiffness that you want in track for direct responses, precise tracking, and also to keep, again, the aero where it belongs. There are 4 separate cals in the vehicle. There is an on-road comfort mode, there is an on-road sport mode, and there are 2 track cals, one of which is a smooth road cal and one of which is a kind of a bumpier track calibration. So you have driver selectable 2 options in track mode and then road selectable 2 options. The primary advantage of going to a spool valve architecture of the shocks is spool valves allow much more tailoring of the force velocity curve than you can get typically with a shim-based system. So what that does for a car of GTD's capability or for any track cars allows you to have very, very precise and very, very locked down low speed dynamics. So the shocks provide a significant amount of force for things like turn-in, braking, lateral acceleration, and those types of things that would typically disturb a body where you put in a lot of what we call primary motion, right? So the shock is damping that in a very critical fashion. However, you're able to open up that shock and reduce that damping force significantly for things like impacts, right? So as you drive over a bump or whatever else, you don't want all that harshness either on the road or on the track, right? The key to getting the most grip you can mechanically out of the tire is to reduce what we call CPLV, or contact patch load variation. Bumps will typically increase the loads of the contact patch because you're accelerating the tire and the wheel upwards. The more the shock resists that, the more variation you get of the contact patch, and on the backside you lose contact with the ground. A spool valve allows you to very, very tightly control the very low speed body motions while also blowing off very well for the high speed motions and keeping the tire in contact with the ground more than you're capable of with a conventional shim-based shock system. Spool valves also have the added capability of reduced cavitation sensitivity, so you can run lower internal pressures which decrease the friction inside the shock for better compliance and better grip. The push rods allow for numerous benefits in the back. The first and one of the primary ones, honestly, is packaging. We can get a 345 rear tire in there without having to get a coilover next to it. So the push rod allows us to relocate that shock and spring system to a place where we have a bit more room, and we can actually not only react the forces in a better fashion on the subframe where it's designed, but we can also show it off to the customer through a window, which is kind of nice. The other important part of push rod suspension, the reason they're used in a lot of aero cars and the reasons they're used in a lot of race cars, is we can finely tailor what we call the motion ratio, or the rate at which the wheel moves versus the rate at which the spring compresses. So in high displacement compression events where you've moved it up significantly, you can now make a spring that's typically a straight rate spring into a rising rate spring solely from changes in geometry at the bell crank and how the moment arms work as the push rod moves the bell crank through its travel. Moving to a transaxle in the car is a huge enabler for power down in the vehicle. A vehicle, again, with this amount of power and the amount of torque that we're talking, that needs a predictability, distributing that weight onto the rear wheels, which are the two wheels that are obviously giving all of your mechanical motion to the vehicle, helps to add a level of traction to it that is difficult to get when you have a more front biased weight distribution. Additionally, you tend to spread the load more evenly between the front and rear tires, so your tire wear is better. You don't tend to overload a tire and then overheat one section of the car, so your balance tends to remain more stable throughout any one stint than it would if you had, say, significant amounts of weight on the rear or significant amounts of weight on the front, where you're asking that much more of that tire or that pair of tires and then reducing the grip as the heat builds up in those tires. So the brake system on the GTD is also a step ahead of what we've done in the past. The car has four-wheel carbon ceramic brakes, which do amazing job of dissipating heat while resisting fade. Stopping distances, of course, are very, very short, much shorter than anything you'll be used to in any of our vehicles due to the huge tires, the aero, and the capability of brake system. Also, it's an electronic brake booster system as opposed to a vacuum-based system. And some of the advantages that you get out of an EBB system versus vacuum is the brake pressure builds immediately. So as soon as you come off the throttle and you go to the brakes, you get a step function in that response, an immediacy. And we've tuned the ABS for that immediacy of response to take advantage of that faster rate of brake pressure build that you can achieve through a vacuum system. Also, as I mentioned before, the disturbance rejection is phenomenal in this system. Braking over bumps, braking over cracks, broken pavement, those types of things do far less to limit your longitudinal deceleration than you may have seen in previous generations of ABS-style systems. The level of feel in the steering due to the lowered friction on this car is frankly a step beyond where we've been in the past. We're pretty excited about it. Additionally, as far as isolation, there is not a lot of really significant chassis NVH in this car. It's a bit more finely tuned and isolated than you might think for that. So you're not going to get a very buzzy, high impact harshness track ride out of this vehicle, either in the on-road or in the track modes. Anything you're going to get is going to be pure information and not something that's extraneous to what a driver needs to go fast.
Part of the original discussion and development was repurposing the GT3 Mustang engine spun up by Ford Performance. However, the idea of having big power and torque numbers won out, and repurposing the Predator V8, despite its weight and other compromises, was the way forward.
So I've been at Ford over 30 years. Kind of started out with base engine design, piston and rod design, right from the beginning. First double overhead cam, V6 engine, and then from there I had the opportunity to move into racing. And so we've taken the Coyote and we've bored it to 94, spray bore block, and we've stroked it to 93. So we've taken that with a cross-plane crank, and then we've supercharged the engine. We had to do some minor things to beef up the architecture, obviously a new piston and rod assembly and improved crank forging. And otherwise the engine is extremely capable. The supercharged engines are so wonderful because you have instant power. And we were so successful with the increased airflow in and out of the engine that it makes 815 horsepower, so it's going to be tremendous on performance. But we really focused also on the torque band and how it pulls. And so we know it makes 664 at foot-pounds at 4,800 RPM, but it makes over 600 foot-pounds from 3,500 to 6,500. It makes over 500 foot-pounds from 2,500 all the way to redline at 7,650. To get the increased performance we wanted for the GTD, we really focused on getting air in and out of the engine. So the key here is reducing the induction losses, putting a smaller supercharger pulley on, and reducing the exhaust losses. And then we took advantage of that. We were able to increase engine speed a bit as well. We worked at making it work with port fuel so that we could package the largest supercharger we could get in the valley and not have problems with packaging with the DI system. The dry sump system that we use on the 5.2, it's the first time we've done it, especially with this V8. It took a lot of development. We worked very closely with our engineering partners, Roush, to develop a very clever system to do this dry sump and package it in this car. So a dry sump, the key to a dry sump is to get the oil away from the crank train, get it to a separate tank, let the oil settle and de-aerate so you have nice, high quality oil, not aerated. And you can feed your hydraulic valve train and your crank train and have a robust engine operation under high G loads. So as you know, the car can pull over 1.5 G in braking, over 1.35 G in cornering. A wet sump system sometimes struggles to keep enough oil in the pan to have continuous oil feed to all of the hydraulic systems that we have. So we go to the dry sump, it corrects that problem. Now, where do you put the tank? That's the key, and we always struggle with where to put a tank with a dry sump system in any car, and we've studied it a few times. This time, we came up with an elegant solution, and it's a structural oil tank that's mounted directly behind the engine. And what that does for us is it gives us multiple benefits. So we get rid of external oil lines, and when you get rid of the external oil lines, you don't have to worry about all the reliability issues of external oil lines. You also get rid of the pressure drop problems that you have with external oil lines. And then the tank packaging itself. And so what we end up doing now is the output shaft connects to the dual mass flywheel, runs through the oil tank, through the rear engine mount system to the flange that ultimately drives the prop shaft to the transaxle. So it's a very elegant solution. Part of the key with the dry sump system is you got to pump the oil-air mixture out of the oil pan to the tank. So we have a 4-stage scavenge pump system that's belt-driven on the side of the oil pan, runs internal passages back to the tank. Once the oil settles, then that oil's fed back to the G-rotor pressure stage that's crank-driven at the front of the engine. Surprisingly, when we did the 500, we did it, we've got a pretty robust system. So we could work on airflow and improve the airflow in the front of the car and the aerodynamics and really get where we needed to be. The transaxle, we learned a lot with Tremec together when we did the DCT for the GT500. We want to be sure that we have the fast shifts, great shift quality and shift scheduling, and we want to be sure that we have great differentiation between a normal mode, that's driving every day, sport mode for that spirited mountain driving or whatever you may want to do, and then the track mode. And then the ability to very quickly shift from an automated schedule to a manual schedule and have the automated schedules, even in track mode, it's set up so that it makes every driver feel like a hero, really. You can drive it as aggressive as you want in automated mode, and you will find that it's shifting as a seasoned driver would want it to shift if he was shifting it himself.
Jack, GTD. I have some severe trepidations about this car, and we've been in your previous car that had JRZs, we're in the GT500, the GT350, the Dark Horse, and now this, and I look at the price tag and I think this better deliver the experience.
Well, Mark, this is one hell of an experience car. I will demonstrate to you why I think this is one of the most special cars we've driven on this channel, sir.
I don't know about that, Jack. Let's see.
Oh! Whoa! Whoa! say anything, Mark. I want you to experience.
What, experiencing no AC now because we're driving flat out? You're gonna cook me in here like a casserole?
Oh. All right, Mark. So, everyone's so lap time obsessed these days that that's all anyone's talking about. Is this faster than the ZR1 or GT3 RS?
It feels
what I'm gonna
faster.
say is that this car is such a unique experience that it just, I don't think it matters, honestly, right? This car is a big front engine, supercharged V8 muscle car that feels more like a Trans Am car than anything else. It feels big. It has such an insane amount of mechanical grip. Probably some of the best brakes of any street car I've ever experienced. And while it is a digital car, you have brake-by-wire, you have, non-hydraulic steering.
I think a lot of brands should be studying, sadly, is this $400,000 Mustang of how to calibrate suspension and brake-by-wire, especially the brake-by-wire calibration is probably one of the best things about this car, is the repeatability and brake feel and the way that it responds under braking and the utter confidence that you get for being over 4,400 or 40?
With us in the car, because of the 400 pounds a person in this thing, you're probably pushing 4,700 pounds right now. It is.
So, just that's all you need to know is the fact that you can get repeatability, confidence, and then this rewards somebody that's going to go out here and grandma their, supercar thing, or if you're a really good driver, man, we said it about the GT350, that it rewards amazing driving, and this is just like ×3. It's so incredibly exciting to drive.
The way you can back the car into corners, the fact that this car, despite making all this power, is 0% rear tire limited. It's super balanced. If you run the front off a little bit, it pushes. You get too greedy with a throttle that moves around, but it's super predictable, and as this car falls off tire-wise, lap after lap, it does the same thing every single time.
Yeah, the V9 guys got the predictability right, and that's something that Mustangs struggle with. And now clearly, if you're ham-fisted, and I noticed, if you start to dial in more steering in a corner and you overwork the front end, it will oversteer on you. So you got to be a little bit more delicate on the steering as you get extended lapping. But to make this car as precise as it is it's just like an absolute feat. And I know the argument is it better be fucking good for this price point, and that was how I was going in. It definitely meets or exceeds my expectations of how this should
walk me through the input stuff. Steering first.
It's got more load up and overall feel than the GT3 RS, and I want to say this, the fact that we're comparing this car to the GT3 RS is no joke. It definitely has more steering feel. You know what the car is doing. It helps that you have more weight over the front wheels. Obviously, all the inputs are basically one-to-one. The throttle is not synthetic. The brakes are an on and off switch on the track, but in a good way. You have immediacy that you don't get from a true hydraulic system.
I think they're far better calibrated than the ZR1, let alone the Z06.
Oh yeah, the ZR1 feels like a GT car compared to this. This feels like a real track day focused car that you can go pretty much on every track and just absolutely tear up.
I think the gearbox too, despite being the same family as the ZR1, is better calibrated.
It's so sharp, it does everything you want. There's very minimal hiccups in auto mode. Manual mode always responds.
It's entirely transparent to the driver. I guess my only cons are driving experiences. In tighter sections of the track, you can't fight physics. The other con is, unlike a ZR1, you can't run AC on the track, so it's probably about 500 degrees in this car right now.
So this is two major things. If you're using this on the track, you got to come with a cool suit for extended lapping. It's really hot out here today, and we're absolutely roasting in this car, and that's going to probably be a big deal for somebody who's older. Oh my God, bro. And the other thing is, unlike a car like the GTRS, which doesn't have as advanced of a damper system as this, this is probably one of the most esoteric damper systems of any, like one of the modern cars in this price point. You you don't have a lot of calibration choice on the track. You basically have 2 modes, and it's designed around very smooth surfaces. So when you get out here, the high frequency stuff in the bumpy sections, even in the straight, you notice it and you can't really dial it out. So I would like to see more calibration options and adjustability since the shocks can take it. The GT3 RS, you can cater it to every track. This is kind of like, hey, if you're on a bumpy track, watch out.
I think this is one of the cars, well, I mean, to be fair to your point, this is a car that should be amazing to drive.
Oh,
But one of the cars that I'm most impressed by this year.
dude, this is fucking incredible. It's absolutely incredible experience. I mean, would it be my first choice if I had unlimited money? No, but I would have it in my garage.
I think as an experience, as it is now probably 140 degrees in this car, my arms are soaking with
Dude,
sweat.
I'm like literally, I can't grab on anything. I'm just dripping. The handle is like a slip and slide.
If I had one car that I needed an experience with, I'd take this over a 3RS.
Oh, this is one of the best experience cars. There's no doubt. You know, people ragged on the LFA when it came out because it wasn't proficient, it wasn't fast, and that car is an experience car in a different way. This is like the American experience where it does everything great. It's fast as fuck. It handles well, and it puts a huge smile on your face with V8 noises and power slides. Oh!
So with that, sir,
Oh, the final thought, take me out of the microwave, dude. Now that we're fully recovered after that drive, Jack, I had to shower off after you ran me ragged. And what I want to say in closing is this video and videos like this, the amount of moving pieces that it takes to do this, like just the amount of gear that we use, the amount of resources. You could take a look at our happy photo at the end of the day with all of the resources from Autobahn Country Club, Multimatic from Ford, the amount of effort that Brandon Turkis had to do from the PR side. And Jack's like, oh, I called this guy 6 times, and I'm like, dude, this guy's gonna quit his job. I mean, it's unreal what it takes these days to get a lot of these videos done because of the amount of information that is required and the engineering effort from Steve and everybody we talk to. This is why I continue to do this, is because we can tell the back end stories of how things work versus just like,
It's
it's
fast
cool.
and fun, yeah.
Right. Everything's fast and fun to a certain extent. But I really like sharing this, and I appreciate that Ford they went way out of their way to make sure that we had the information we needed.
This is always what we wanted to do when we started this channel.
100%.
Learn from the people who actually made these cars. And Ford has told us numerous times during this project, they don't do this. They never give access to
Now
this
you know
level.
why. But to be fair, what I will say is that we're very, very lucky that we're one of the few people on the planet that gets access to engineering on new cars, to the people that work on them. And then we're one of the few that actually get to drive every single new high performance car, new technology on the track, on the street. So our driving abilities and our ability to connect with cars, even development drivers and a lot of the brand's engineers don't get to drive as many cars as we do. So we have a much better appreciation of taking the engineering and how things work and what it's really like to drive them at the limit and on the street. So we have a really good basis for comparison. And I think the GTD, despite its price tag, and if I'm gonna turn off just that part of myself and I'm gonna turn off the engineering part of my brain for a minute, this car was probably the pinnacle experience I've had on track other than the GT3 RS. There's nothing that I've felt that combines the emotion and the fun to drive part, along with not being frustrated driving this car fast. It is just so much fun. You think about it afterwards. I can still think about it now with fond memories and think, I want to get back in this car. And that's so rare with all the cars that we drive. And there's something to be said about that as well.
I'm going to say about the car, I entirely mirror Mark's comments. It is one of my favorite things I've ever driven because it makes you laugh. It is a pure, like, it relates to like the boy inside of me still that loves cars for the sake of driving and just enjoying myself. I think as a society, when it comes to cars, We are so obsessed with lap times and stats and figures. Look, you don't drive its Nürburgring time. Behind the wheel, I don't care if it's faster or slower than a GT3 RS or a ZR1X or a ZR1. I don't care how much it weighs. I just love the fact that I feel something through the steering wheel. I feel something through the car. You hear an engine that is basically gone in this segment. Nobody makes front-engine supercharged V8s in this class.
Yeah.
Everybody's moving to a mid-engined twin-turbo V8 of some kind, and they're all becoming hyper-homogeneous. This is its own car, its own experience.
Yeah.
And that's why I love it so much, to be honest.
So I have to turn back on the engineering side of my brain and the practical side, Jack.
So the big first negative is when you compare it to some of its rivals, it is even more money. And I mean, realistically, you're starting in the low 300s, but by the time you option on the performance package and color options and interior trim pieces, you're pushing past $400,000, which is more than a GT3 RS and honestly a Ferrari. And the price is one thing, but as a day-to-day experience when you get inside the car, it still is saddled, no pun intended, with a Mustang interior. The S650 interior is very prevalent throughout this, and it's probably the worst interior in its class by a substantial margin.
And I think you're being really nice about it. I think this is a car that deserves more. The engineers want to do more. You can tell that when you compare it to its competitors instantly. If you park this next to a ZR1 and a GT3 and you get on the inside, you're like, this feels like a $25,000 car, and there's no excuse for it in this price category. And I understand that there's only a limited amount of money to do cars like this, but it does not compete, and it's embarrassing. If you want to be like world class and you want to have that, you gotta have the attention to detail. You gotta sweat the attention to detail, which the screens are not attention to detail. No. This is not like a pure focused sports car interior. It's just like trying to do too much, and it is built to a price point, and they need to address it. But that doesn't take away from it being, I think it distracts from all the great things it does. The other thing is the weight. And the weight, you can't hide it because this is on a body in white that was designed probably over 10 years ago, to be honest. They haven't had the structural optimization done to reduce the weight out of it. They've carried it over to the maximum. And despite all of their hard work to mitigate it, the weight cannot be removed out of the equation, and they're having to overbuild so many other parts of the car, including adding a beastly engine that weighs conservatively at least 250 to 300 pounds more than if they would have done like the naturally aspirated version out of their GT3 car. If they would have taken a race engine mentality, you would have dropped the weight there. The additive mentality of modern sports cars of continuing to add more weight and more and more weight, where does it end? Is despite how great it is, you can't hide the weight on it.
I think it's when you put it in contrast to like the mid-engine architecture of the C8 or the modular architecture of the 911s, this is a far less sophisticated chassis. And to Mark's point, the weight and the spiral from that weight does hurt this car. There's no way sort of around it.
Right.
The other thing, or the last thing I'm going to bring up as far as a negative, is the seats. While they are excellent on the street and they're right out of the GT500 behind us, on the track, those seats for the GT500 were never meant to carry the sort of G-forces the GTD can produce. So you are actively being tossed out of your seat. And as you saw in the video, this is one of the hottest cabins I've ever experienced. Yeah. If you drive the car the way the engineers want you to, which is with the windows up for maximum downforce, you could cook a casserole in the backseat.
This is just, again, the seat problems, the interior, part of the interior mentality. You're trying to take something that wasn't designed from the get-go. This was not designed from the ground up to scale out to be this type of car, and we know that. So you have all these little problems that you're trying to mitigate and Band-Aid fix versus just doing it right from the get-go. And I hate to say these guys because I'm not a Corvette guy, even though I'm trolling with the hat. They built the C8 from the get-go because they knew the ZR1X was coming, right?
They never did that for the Mustang.
The Mustang is not that car. So again, these problems can be mitigated if you plan ahead and you think about that. And hopefully they do that in the future. And again, the cooling issue with the interior, with AC flipping off when you go flat out, it's a big engine. A lot of cooling required. So, naturally aspirated engine, there's a reason why that's used in racing. A lot of heat generated from that. So all these things, as great as the car is, it still has some problems from them to work out and sort out. But I will, again, counter that with the fact that this is one of the most exciting cars I've ever driven in my time of doing this. And it took some serious brass balls to greenlight this car and see this through. I mean, like, the balls on these guys. Like, let's take a Mustang and do this. And somebody's like, yes, we're going to do this. I thank God they made this thing. I'm so happy that I got to experience it and be proven wrong that you know.
This is the biggest 180 I think I've seen you experience.
Yeah.
I'm Johnny Positive and you're Johnny, well, you're Larry David in these videos,
sure.
real negative. And after our like sort of first meeting, you're like, oh, this thing's gonna be a turd. And then when we actually got to drive it, you're like, this thing's incredible. And that's the only time doing this with you for however many years that I've seen you do that.
Yeah, completely.
So with that, I definitely have some people to thank. Huge thanks to Ford Performance, Multimatic, and of course all the various people at Ford we've had to deal with, because this project is taking like 8 months to get done on our end. Huge thanks to our Patreons. Without them, this would not be possible. And we have a Patreon page which we never promote, but please go to it if you want to see more projects like this. Thanks to our title sponsor, Bridgestone Tires. They've been a longtime supporter of this channel. Without them, honestly, videos like this would not be possible. Go buy a set of Bridgestone tires for anything you own in your rocking chair.
Put some lenses on your GTD.
And huge thanks to Autobahn Country Club. Without them and their partnership with us, we wouldn't have a track to make videos like this. They've supported us for years. So if you want to become a better driver, check out their Performance Driving Academy, become a member, join their karting club, do a track day there, look at their calendar. And if you just want to experience all that Autobahn has to offer in Joliet, Illinois, please head over there and tell them that we sent you.
And one of the members just bought one of the GTDs. He's there, he's waiting to take delivery. So if you want to see cars like this and you want to experience cars like this, hey, you know what? Move to Illinois. Our property taxes are great here. come buy a car and go to Autobahn.
All right, so with that, thanks for watching, and here's a clip of something.